Hello everyone and welcome to another video on Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user-defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I passed, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before every in every method I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional, we don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now, if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods, and this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now, when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now, let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called myClass, and the second print statement is basically a string saying hello from the string name myClass with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class, my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like at class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the @static method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. In our next video, we will be covering the next topics of OOP, and we will be starting with inheritance in our next video. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3, and I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that well, this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called showState, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1 we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have 2 methods again. One method is called setMarks, which has the option of putting in 2 attributes, M1 and M2, both representative of the 2 marks, and we store them in self.mark1, self.mark2. The second method is putMarks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called a result, which derives from two classes, marks and student, as you can see here. In my parenthesis, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have two methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result. I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so his name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do R set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I had written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called set stud and put stud, or you can call it set student and put student. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called set marks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2, and finally we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier, but the only difference is in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1, where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1, and I'm going to say after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3, and this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y. And since I've done this twice from two different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, two attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called setMarks, where we can pass two attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a putMarks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has two methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have set marks, which is again the second level parent, which is the student class, where we set the marks. Finally, we access this get practical. Now, if you notice, get practical is part of the practical superclass. So in this, we store the third subject, or the practical marks 100. Then we calculate the total, and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. So this was it, guys, for our video on inheritance. Again, we will continue with our topic of object-oriented programming with the topic of polymorphism in the next video. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example, where we are able to use the plus operator for different operations, is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now, if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now, method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now, for example, what I'm going to show you here is an example where I have a method called sum. Now, by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now, if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8, and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8, and 9. So in this is not a very used, not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C, I have a default value of 0. I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is, when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define the initializer is 2 attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is, it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store 2 attributes x and y. in self.x and y and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also wanted to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator or the special method to provide functionality for the plus operator in Python is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point, and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate, and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffix with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point, and I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator, where I'm going to basically allow the this asterisk operator to multiply 2 objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default, it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1 dot name, and it will say earns more than object 2 dot name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. Well, this was it for polymorphism.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this video, what we will be covering is certain abstract data structure concepts, and we're going to implement these abstract data structures using basic Python techniques, and also we're going to get slight introduction into object-oriented programming to perform these or to create these abstract data structures. So you can consider this as an exercise or an activity in OOP plus some basic Python concepts. So let's talk about what stack is. Stack being the abstract data structure that we are talking about over here. So the name stack resembles a pile of objects, right? It can be a stack of papers, a tower of blocks, where adding and removing of an item occurs only at the top of the pile. So a stack is an abstract linear data type, which is a collection of objects that supports fast, last in, and first out semantics for inserts and deletes. Unlike lists for arrays, stacks typically don't allow for random access to the objects they contain. So you can't just access something by an index in a stack. You either go from the top or the bottom of the stack. So what we are going to use is insert and delete operations, which are often called push and pop respectively. Stacks and queues are both linear collections of items, but however in a queue, the least recently added item is removed first. So it follows a first in, first out approach. On the other hand, in a stack, the most recently added item is removed in the beginning. So it's like last in and first out approach. So a real life example of a stack is a pile of heavy and precious plates, all kept on top of each other. So if you wish to remove a plate, if you wish to add a plate or remove one, you can only do that from the top. And if you want to remove a plate from the lower bottom of the stack of plates, you have to remove from the top one by one. In a practical example, of course. Used for real world analogy for a stack data structures, of course, stack of plates. It can be a pile of clothes as well, where you typically want to remove or put everything from on top of the pile and not in the middle or the bottom of the pile. So yeah, so this is a visual representation of a stack where this whole it's a linear collection, but whatever we do is usually something to do with the topmost item or the last entered item of the stack. Now basic operations that can be performed in a stack are mentioned as follows. So there's a push operation, which basically adds an item to the stack. If the stack is full, it is called it is said to be in an overflow condition. there's a pop operation which removes an item from the stack. It follows a reversed order to pop items, similar to the way when items are pushed. So in that case, we call it an underflow condition. Now there's peek or top operation, which basically returns the top element of a stack, and then there's the is empty operation, which returns true if the stack is empty and false if it is not. Now the applications of stacks, like where do we use them? They can be used to reverse a string. It can be used in expression evaluation, expression conversion. It is used for forward and backward features in web browsers. It is used in recursive parsing in NLP, and so many other operations are there and applications for stacks. Now let's understand stack operations. So the two most basic operations are, of course, push and pop. Now when we want to push, what we're basically doing, let's consider an example. So let's consider editing a Python file using the undo feature in our editor. So we have a clear understanding of the stack operations. So at first, say a new function called insert is added. The push operation adds the insert function into the stack. So this is a visual representation of what we're talking about. So we have this empty list, this empty stack initially, and what we're going to push onto this is the insert. Some function, say let's call it insert, or some object called insert. So once we've done this stack looks like this. It has an object called insert, right? Now a word delete is removed. Let's look at the next thing now. Let's say I push something called delete now onto this, right? So if I push delete, some object called delete onto this, it goes on top of the insert stack, right? Because this is a stack. Everything occurs in a top, like the last thing that you have added is the first thing that you will see from the top. So we see delete first. In terms of our example of our Python script, assume the script as the whole stack, where we initially had a function called insert and then we added a function called delete. And now in the same script, we want some comments for each of these functions. So think of it as another object that we're going to add on top of all of this, right? So now we have this Python script where we have the first function called insert, the second function called delete, and a bunch of comments pertaining to these. And that's the last, basically, that's the last object that we added to our Python script. Now let's perform some pop operations. So the first, like say we did undo. Now we have a Python script with all of these things. Now let's say we pressed undo for something. Like say we press undo. Well, what is the first thing that is going to go? Of course, it's the last thing that we entered, right? And the last thing we entered was a comment. So when we press undo, what gets popped is the topmost thing, which is the comment. And the comment is now gone. And what we have left in the script is the other two things. And if we hit undo again, well, the next thing that would be removed is the next most recent thing that was added, which was the delete function. And then if we hit undo again, the insert function will get removed. So this is how the pop function and the push function works in terms of stack, where I gave you the example of the undo operation in a Python script. Now let's implement a stack in Python. There are some basic implementations, and they are as follows. We can use lists, we can use collections.deque. I'll show you what that is. And we can use the custom method, which is basically the OOP example that we were talking about. And there are numerous third-party packages which we may or may not look into. But for the sake of this particular video, we're going to be looking at these first three cases in particular. So let's look at the first option, which is a list built-in. Now the Python's list object type already has a decent stack data structure approach, as it supports push and pop operations by default. So let's create a list called S. Now what I'm going to do is I'm going to append this list with a bunch of strings. So first I'm going to append it with eat, sleep, and then code. So if you see here, if I print my list that I'm going to treat as a stack, these are my objects, right? Now if I had to pop from this list, your question would be, well, what is the first object that comes out of this list? Well, since we're going to treat this as a stack, and since pop is a stack operation, it will pop out, or it will remove the last most added, the most recent added object, which was the string code, right? So if I had to execute these, you will see when I do the first pop, the object that gets popped out is the last thing that was added, which is code. Now if I did pop again, it will remove sleep, because that was again the next most recent one. And finally, if I did pop again, it will remove eat. It's important to note, oops, 1 second. So if I do this, then if I did pop, and then, okay, so what happened here was basically the pop. Okay, so I'll tell you what. So let's look at an example where I'm going to be using this. So let's define my stack as some list S, and I'm going to append eat, sleep, and code to it. So the first object that gets appended is obviously eat, then sleep, and then code. So if I were to pop these objects, the first object that should come out is code, followed by sleep, followed by eat. So let's look at what happens when I actually try doing it. So let's print out what's in S. So if you see, this is basically my list S. Now my first pop should remove code, as you can see. My next pop should remove sleep, as you can see. Finally, it should remove eat. Now the question is, what if I did pop again? Well, an underflow error would occur. So if I did pop again, you see this error, and it says you cannot pop from an empty list because I have popped every item, which were 3 items, and the fourth pop well, there's nothing else to remove from the list. So it gives me an error. Our next option for stack implementation is using the list, using the collections.dq. So this is a basic, it contains, basically Python has a module called collections. It comprises of the dq class, which is a double-ended queue that supports inserting and removing elements from either ends of an object. So since dq support adding and removing from either side, they can serve both as queues and as stacks as well. So let's import this dq class, and I'm going to create an object called queue of class dq, and what I'm going to do is I'm going to do the same thing. I'm going to append eat, sleep, and code, as you can see here. Let's check what's in queue. Well, it's a dq object of it's an object of class dq with the objects eat, sleep, and code. So again, if I did the pop operations, it should remove code, sleep, and eat in that order, because that's the reverse order in which I have added them in, right? So let's look at it. Code gets popped first, then sleep, and then eat. And of course, if I try to pop even further, it should throw me an error because it's an empty dq now. There's no objects left in it. Now the third object is using custom. It's using custom method, using classes and objects. So this is basically our example of how we're going to create a class and use basic concepts of object-oriented programming to create our stack. So let's start working on this. So the following stack implementation assumes that the end of the list will hold the top element of the stack. As the stack grows, basically as the push operations occur, new items will be added on top of the list. Pop operations will manipulate that same end. So let's create our stack. We are going to create a stack class called stack top n. It'll have an initializer which will basically initialize a list called items. Now once we've done that, we're going to so this is basically the str function. Don't worry about this. Let's look at these functions which we are concerned about in this particular example. So we have a after we defined our str function, which is basically what it's going to do is going to print the contents of the stack that we have when we invoke the print function for a particular class object. Now the custom functions, the custom methods that we have created are isEmpty, push, pop, peek, size, and display all items. They're very similar to the predefined push, pop, peek functions, etc. So what these will do is the first function isEmpty is, as the name suggests, it's going to check whether the list called items is it empty or not. If it is, it will return true, otherwise it will return false based on this check. The push function, it's going to append an item, whatever we pass to the list items. The pop function on the other hand is going to do the pop operation, as we have already seen. The peek function, what it's going to do is, if you see here, it's going to give us the item in the lastmost index. So if a length of a list is 10, then its last index is 9, since Python is zero-based indexing, right? And if we want that last index, we can just do length of that particular list minus 1, and then we can use that as an index for our list. So this is basically what's happening here. We're going to check for the last item in the list called items. So yeah, penultimately we have another method called size. What this will do is basically return the length of our object of our list of items. Finally, we have the method called display all items, which is going to return the list itself. So let's initialize a stack. We call it S. As you can see here, let's execute this first. Now we initialize this. We call it S. Now we print S. What it does is, well, it doesn't do anything, because what the printf function should do is it should return us the stack contents, which is nothing right now, because we haven't added anything to our list. So we check if it's empty, and we see, yeah, it is true, it is actually empty. So let's start pushing items into this list. So the first one that we push into it will be called will be a string called first, then we push second, and then we push third. So let's do this. Once we have done this, now if we print the this object s, it should give us the stack objects or the stack contents, which is, if you see here, what I've done is actually I've actually pushed first, second, and third twice by mistake. So it basically contains a list of first, second, third, followed by first, second, third again. Again, this is not an issue. We can work with this as well. Now let's look at the most recent item inserted. So since I have entered first, second, third, followed by first, second, third again, so this list is basically a list containing these objects, right? Like first, second, third, followed by first, second, third. And if I were to peek, now what was the peek function? The peek function looks into the lastmost object. So the peek function should look at the object that I added most recently, which was the string called third. So if I print this, it should give me third, which it does over here. Now if I wanted to view the stack, it's a simple, I can iterate through all of this and print each item. As you can see, since I have added it twice by mistake, what I'm going to do, what it's going to do is it's going to give me everything, as you can see here. So it basically, what this means is my stack contains the objects first, second, third, first, second, third. Similarly, I can also use the display all items to do the same thing, to show the same thing, as you can see here. Now I can add a boolean. So what this push will do is it will add a boolean object called true. So if I push this to it, now this stack contains a boolean object called true as the last object. So let's see. So if I wanted to see what s contains now, what I can do is I can do display all items and check. Let's see what is there now. So if you see, I have my objects here, but now since I added a true object, you can see that over here as well, a boolean object called true. Now let's print size of stack. So we use the size function. It should be 7, as you can see here. Now let's push another object. So this object is a float object called 8.4. And once I pushed it, and if I want to display everything, as you can see, now I have finally another object called 8.4 in this. So if I were to pop now, what will it pop? It will pop the recent most added, which was the float called 8.4. And if I did that, as you can see, I should get 8.4 here. Finally, if I were to display whatever is left here, it should display everything except the 8.4, which I have popped earlier on, as you can see. So in this other implementation, what I'm going to treat the top as is the beginning of the list. So the 0th element is going to be my new top now for the stack. So let's look at how things change because of this. So again, I have initialized a list, an empty list, and I'm going to have something, an isEmpty function to check if the list is empty. I have a push, which will basically now not insert objects from the last. It will not append objects anymore, but instead what I'm going to do is I'm going to insert objects to the 0th index of the list item. And when I do pop, it won't remove the item in the last index, but it will remove the item at the 0th index. Similarly, peek function will also do the same thing. It will look at the list from the left hand side. So it will look at the 0th index object. So that's the peek, and then the size is the same thing. It's going to return the length of the list, and display all items will do the same thing once again. So now I have, once I've created this, let's create an implementation called stop 0. Now is stop 0 initially empty? It should be true. Let's push first, second, and third now. Once I push these, let's look at what was the most recent item that was inserted, which should be third, right? Let's view this stack. Like, how does it look? So if you see here, if I print them one by one, it prints third, second, and first. So even though I've added first, second, and third in this order, the items in which I retrieve it is third, second, and first. And that is because of how I defined the stack, where the top of the stack is actually the 0th index. So if I did display all items, it should give me a list with third, second, and first in that order. So if I execute this, you can see this over here. So again, if I did just to see again, my peek will basically give me third. Now using these concepts that we have learned, let's perform an exercise. This exercise is going to be where we are going to write a function where we're going to reverse the characters in a string. So let's look at how we are going to implement this. So if you remember this class, stack top n, from this earlier case over here, we're going to use this class to create an instance of that class. So what we're going to do is we're going to call it myStack. And our input string that we're going to use is called Bangalore. We're going to reverse the characters of Bangalore. So what we're going to do is, first of all, we're going to push each string, each character of the string into the stack object using the push function. And then let's see what our object looks like. So as you can see, we have pushed each character of Bangalore into a list, and we've stored it right now for now. So let's initialize an empty list and an empty string. Now what we're going to do out here is basically the reversing operation. So as long as my initial list, which is called my stack, this object, as long as this object is not empty, what we're going to do is the pop operation, and we're going to keep adding. We're going to append each item that we get from the pop operation and add it to our empty string. So we're basically going to create a new string with letters that we pop from this particular list, which is basically what it's going to do is it's going to pop E, then R, and then O, and we're going to add it one by one in that order and create a new list, a new string out of it. So this is how we're going to do a reversing string operation. So once we execute this, and we're going to print what is the reverse string is. So if you see here, the reverse string in the form of a list is like this, and if the string form of the reverse string is, as you can see here, which is basically Bangalore reversed. As always, I thank you for watching this video. I hope you learned something about the stack, the abstract data structure in Python, and how we implemented it using basic Python lists, dequeues, and an object-oriented approach to the same. As always, like, subscribe, and share this video with your friends so we can reach out to new learners. I hope to see you in the next video, and thank you for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.